Everyone knows that a giant rock from outer space hit the planet millions of years ago and wiped out the dinosaurs. Now, with advanced technology, researchers have been able to put together a new timeline showing what really happened. And not only this, they think they know where the giant asteroid came from. Is Earth the target for another huge space rock, and would we be able to survive? You'll be surprised and probably shocked at what NASA astronomers recently discovered. So now get ready to experience the disaster that almost wiped out life completely on Earth. The giant asteroid's impact into shallow waters in the Gulf of Mexico 65 million years ago was bad enough. But then an amalgam of additional disasters ensued. Rocks fell from the sky, wildfires ignited, and tsunamis inundated distant shorelines. The researchers found that the first day of the Cenozoic was peppered with cataclysms and released a new record of this day of chaos in Proceedings of the National Academy of Sciences. Their timeline was developed using high-resolution photography, microscopy, computed tomography, imaging, and magnetic measurements of hundreds of feet of sedimentary rock recently recovered from Chicxulub, one of the largest impact craters on Earth. And it all began like this. Imagine you were somewhere in North America about 65 million years ago, when dinosaurs ruled the Earth, and you were looking up at the night sky. You would have probably seen what appeared to be a bright star shining off into the distance. But if you watched this peculiar light for an hour or two, the object would seem to grow in brightness, but barely move. What you would be looking at is not a star, but a huge asteroid, somewhere between 11 to 80 kilometers wide, 750 miles on a direct intercept course with the Earth, at 72 to 420 kilometers per hour, 45,000 mph. Hours later, the asteroid plows through Earth's atmosphere, heading straight for where the Yucatan Peninsula is today. At impacts of that speed, Earth's atmosphere acts like water. Smaller space rocks, called meteors, hit the atmosphere like pebbles thrown into a pond and decelerate rapidly at high altitudes, burning away from the friction of the atmosphere, while some bigger pieces of rock survive and fall to Earth. But the mountain-sized Chicxulub asteroid hits our atmosphere like throwing a boulder into a puddle. It maintained its velocity and plunged through the entire 60 miles of atmosphere in just 3 seconds. The asteroid shrieks over Central America, emitting the mother of all sonic booms that would shatter eardrums across all the continents. The dinosaurs were likely terrified and running in all directions, having no idea what was just about to happen, but if any animal was close enough to see the asteroid, they would have been instantly vaporized within minutes. In fact, except for sea turtles and crocodiles, no four-legged animal larger than 25 kilograms would survive. The mountain-sized space rock falls so quickly that the air itself cannot escape. Under intense compression, the air heats to thousands of degrees almost instantly. Before the asteroid even hits, compressed superheated air vaporizes much of the shallow sea that covers the Yucatan. Milliseconds later, the rock plunges through what's left and slams into bedrock. In that moment, a chain reaction of events occurs. The impacting asteroid exerts so much pressure on the Earth that soil and rock flow like fluids. The flowing up and down movement of the Earth is like the double splash of someone doing a cannonball in a swimming pool. The initial splash in all directions is followed by a delayed vertical splash when the cavity created by the asteroid rebounds to the surface. The first wall of Earth gouged outward at the moment of impact is more than 32 kilometers high, 20 miles. The impact hole nearly breaches Earth's mantle, and when the cavity rebounds to form the delayed vertical splash, the Earth rises at over 1,600 kilometers per hour, 1,000 mph to heights taller than Mount Everest. Within minutes, this mountain of debris almost entirely collapses in a series of secondary explosions, leaving behind a smaller mound called a crater's peak ring. At the same moment the asteroid strikes the Yucatan and applies its pressure to the bedrock, it converts the kinetic energy of a 5 billion-ton rock traveling 16 kilometers per second, 10 miles per second into searing heat in an instant. The Chicxulub impactor delivers approximately 1 septillion, 300 sextillion kilojoules of energy, 100,000,000,000,000,000,000,000,000. More energy than 1 billion Hiroshima atomic bombs. The kinetic energy transferred by the asteroid to the soil, rock, and air excites the molecules to temperatures far hotter than the surface of the sun. The heat rips electrons from atoms, ionizing the air into an expanding fireball of plasma in excess of 10,000 degrees, turbocharged with vaporized rock that is blasted out at hypersonic speeds. The heated, rapidly expanding air and near-instantaneous conversion of Earth to gas, combined with the impact shockwave itself, forms a massive blast wave of pressure, expanding outward at more than 1/1600 kilometers per hour, 1,000 mph. If this asteroid hit the same spot today, the blast wave would vaporize you in Texas, deafen you in New York, and blow out glass windows in Buenos Aires. The Chicxulub impactor rings Earth like a bell. Waves in Earth's crust radiate away from the impact zone at 4 kilometers per second, 2.5 miles per second. These waves then trigger fault-slipping earthquakes across the continents. If you were on the other side of the world, you would feel the ground shaking 30 minutes after impact. The impact triggers tsunamis as high as skyscrapers. The first of them hit Gulf coastlines within the hour. Waves ranging from 600 feet to perhaps as tall as 1,000 feet smash into what is now Mexico and the southern United States and flood tens of miles inland. The waves temporarily reverse the flow of rivers, rushing up riverbeds like 30-foot tidal bores. Tsunamis smash into the eastern coast of the United States, and 6 hours after impact, max out at 600-foot-high walls of water that slam into Europe, Africa, and the Mediterranean coasts. Within 15 hours of impact, waves arrive on every coastline on the planet. Depending on local topography, the ocean sweeps away anything in its path and sucks it back to the sea when the waters finally retreat. It already sounds like Armageddon, but even more disasters are on their way. When the big rock strikes, its splash accounts for 25 trillion tons of Earth that it launches on ballistic trajectories, some at speeds that exceed Earth's escape velocity. These stones left Earth's gravitational draw to either circle the sun, and a portion of this material most likely arrived at the moon. However, most of shot-out trash got once again to Earth soon. These glass-like lumps, called tektites, some as extensive as transports, yet most the size of marbles, pelt the Earth at speeds going from 160 to 320 kilometers each hour, 100 to 200 miles in deadly amounts. Despite where any excess dinosaurs were on the planet, they were hit with this searing hailstorm. Yet these glass shots didn't have to stir things up around town to be deadly. As these tektites fall, their grinding with the air emanates sufficient warm radiation to set fires across the planet. By certain evaluations, the joined intensity of the returning ashes warms the planet to what could be compared to a stove set to cook. The greater part of the world's trees consume, which is maybe why the main bird species that endure the effect are those that home on the ground. Of the couple of bigger land creatures to stay away from termination, virtually all have a few methods for getting away from the intensity. They either could tunnel like little warm-blooded creatures, snakes and reptiles, or get away into water, similar to crocodiles or turtles. Regardless of whether poor people dinosaurs were on the opposite side of the world, they would have expected to find assurance from the underlying intensity impact. In a last piece of horrendous karma for the dinosaurs, Chicxulub ends up striking a region wealthy in oil and sulfur. The effect discharges 100 billion tons of disintegrated sulfur and 30,000 quadrillion gallons of water into the climate, which then, at that point, gathers into gigantic tempest mists and falls back as downpours of corrosive downpour that fermented the seas. In the higher scopes, mainland-wide blizzards store many feet of snow each day, yet the worldwide storm doesn't keep going long, in light of the fact that notwithstanding water, Chicxulub disintegrates and violently launches 150 football arenas worth of oil from the Yucatan bedrock. This oil consolidates in the stratosphere as a dark, dingy layer, covering the Earth like a layer of dark paint. Not at all like the sulfur and rapidly spreading fire smoke. The carbon courses high over the cloud layer, preventing it from pouring down. Furthermore, that turns into another enormous issue. The sediment layer stays in the environment, lessening how much daylight that arrives at Earth's surface by 90% for somewhere around a few years. The underlying oven-like heat welcomed on by the returning tektites is trailed by a profound and dependable freeze. Worldwide temperatures decrease by a normal of just about 50 degrees. The main puts on Earth to keep away from this profound freeze are Madagascar, India, and Indonesia, which were tropical islands during this time. In the worldwide chill, vanishing nearly stops dropping precipitation by 80%. Essentially, every spot on Earth beyond these tropical islands dries into a desert. Where did this Goliath shake come from, and is there another out there set out toward us? Specialists utilizing a supercomputer concentrated on space rock development, utilizing information from known space rocks. The two-part group of Avi Loeb and Amir Siraj recommended that the Chicxulub space rock probably began from the Oort cloud, a circle of garbage at the edge of the planetary group. It might have been a lot bigger comet that was moved off base by Jupiter's gravitational field and sent near the sun where it broke into a few pieces. These parts can cross the world's circle and raised a ruckus around town once every 250 to 730 million years. Based on this review, it's anything but a question of, on the off chance that we could be hit by one more Goliath rock from space, yet when? On Saturday, December 11th, 2021, NASA uncovered that a 330-meter-long space rock named 4660 Nereus shouted past Earth around 3.8 million kilometers, 2.4 million miles at a speed of 6.5 kilometers each second, 14,719 mph. While you probably won't feel that is extremely close, any slight deviation in its circle could put it on an immediate course with us and crush into the Earth from here on out. Cosmologists are following this possibly perilous stone and say it will go in close vicinity to 1.1 million kilometers, 745,000 miles of Earth on Valentine's Day in 2060. Purchase your blossoms and finish those proposition early for good measure. Remember, the space rock that caused the Chelyabinsk blast in Russia in 2013 was only 20 meters in size. Terribly, we have no known method for guarding the Earth from a monster space rock. Nonetheless, NASA's DART mission, or twofold space rock redirection test, will attempt to check whether a space apparatus can independently explore to an objective space rock and purposefully slam into it, causing a motor effect that could push the space rock off an impact course with the Earth. DART's objective is Dimorphos, a space rock moonlet which circles a bigger space rock named Didymos. The space apparatus is set to show up after the expected time, September 2022, when the Didymos framework is 11 million kilometers, 7 million miles from Earth. Nonetheless, it is assessed that the crash will change the speed of the moonlet by a negligible portion of 1%, halting a 10-kilometer wide or greater space rock plunging towards the planet at an excess of 72,000 kilometers. Each subsequent will take significantly in excess of a little shuttle affecting it. Maybe the world would have to attempt atomic weapons like in the film Armageddon. Perhaps you have a thought how we could stop a world completion space rock, and you'll become renowned. Tell us what you think, and try to remain tuned here for seriously thrilling stuff occurring in our universe.